and get started. So thank you for taking the time to be here with us today. This is our final community of practice session where we're focusing in on planning intentional small group and individual supports. The last time we were together, we focused in on whole group and small group acceleration support. So now we're moving up to the next tier when those acceleration supports are not enough to support the needs of our students. What are our next steps? So that's what we're going to focus on today. So once again, my name is Okera Hawkins. I work as a math instructional coach in Washington, D.C. I'm also an educational consultant and consider myself a change agent. Over these last few months, I've been sharing pictures of how my family has been changing and adapting. So this picture here is a picture of IDL late last month when it was about 75 degrees, well, about 65, 70 degrees and sunny outside. We were able to get her outside and take her for a walk. So she was donned with her fancy little shades. And of course, she can't go anywhere without her binky. So she was ready to rock and roll. So just wanted to share that. And one quick fact about me, I cannot wait for summer to begin. Just to be able to sit outside and enjoy the nice warm weather, barbecue on my grill, just some of the things I'm looking forward to for over the next couple of months. A couple of quick logistical things. As always, if you're experiencing any technical challenges, shoot me a quick message. As always, we're going to leverage the chat as often, and we're going to have it as an alternative in case people are unwilling or, rather share in the chat versus coming off mute and sharing. So just make sure when we're doing that we chat everyone. Also, when you want to exit full screen, you can hit on the view options that will allow you to exit full screen. I won't be sharing too many resources with you today that you'll have to click through, but just in case, that's always available. And as always, the session is being recorded and this information will be sent out to you at a later date. Just in case you don't have it, I just dropped the link to the note catcher again. It's going to prompt you to make a copy. Definitely, as always, highly recommend you save this somewhere where you can find it later so you can refer back to the materials and the resources that are embedded within this note catcher. All right, and as always, our norms for our Zoom communities of practice meetings, do your best to stay present. When you're not speaking, keep your microphone on mute to avoid any background noise. You will have at least one opportunity to engage in breakout rooms, so definitely engage with your colleagues in that small group setting. Use the chat feature when prompted, and I've already shared the materials with you via the chat. All right, so before we get started, I want you to think about how your mathematical experience has been either as a learner or as a teacher. And I have several images on the screen. And so thinking about your mathematical experience as a learner or a teacher, if math were weather, it would be blank because. Now you have the option of picking one of the images on the screen or selecting another image that you think would best describe how you would fill in the blank regarding this question. All right, so I'm gonna give us about 90 seconds of processing time. During that time, go ahead and start crafting your response. And then when you are ready, go ahead and hit enter. And then we'll see some of the responses that our colleagues are sharing. We'll talk about a few and then we'll move on. So 90 seconds is going on the clock now. take 30 more seconds. And as you are ready, go ahead and drop your responses in the chat. If math were weather, it would be blank because. So thank you, Jeff, for getting us started. Jeff says the snow scene, both beautiful and harsh at the same time. I definitely agree with that. Sandy says like the fall picture, usually a nice path, but sometimes students stray from the path and need redirection. All right. Dave says upper right corner, walking on ice. It's always a little precarious. Yes, indeed. The beach scene. Okay, Nick. Both enjoyed with your feet propped up. All right. Okay. If anybody else has any others that you would like to share? I thought about the beach scene as like the calm before the storm. That's the one I was thinking about because, just given it, depending on what time of year. Um, Lightning. Okay. Um, it can be very unpredictable. I definitely agree. So thank you all for taking the time to share in the chat. If you're still typing, go ahead and respond. We wanted to just lift that up because we know that our experiences as learners and teachers play a huge role in how we lead and how we support this work. And so just wanted to take the time to be reflective, to think about how our experiences can be a little chaotic and unpredictable as the weather and as some of these images are displaying. So keep that in mind as we do our work today. So just want to take a moment to do some quick reflections. So the last time we were together, if you were a school-based leader, we asked you to select one teacher to support in planning just-in-time acceleration supports, whether it be small group or whole group based on their data. And if you were a district leader, we asked you to observe the co-planning session that the leader was doing and or observe the teacher's instruction. And so as a follow-up to that, we have two questions that can be found at the top of page 1. So the first question says, what have you done to learn more or support teachers and schools with planning for and delivering just-in-time acceleration supports? Second, what did you learn and what might you do the same or differently next time? So I'm gonna give us about 3 minutes to do some reflecting around those two questions. The second question, I would like for you all, if there are things that you think are relevant to the group about what you learned or what some of the things you might do differently do the same or differently the next time around, I would ask you to share those responses to question number 2 into the chat. So I'll give us 3 minutes to reflect, and then if you are open to sharing, then drop a response to question 2 in the chat. Let's take about one more minute to finish up our reflection. And if you're willing to share something that you learned or something you might do the same or differently next time, go ahead and drop that in the chat as we finish up our reflection. All right, so as we come back together, is there anyone who would like to come off mute and share some takeaways around the second question before we move on? Just want to give space. If you weren't able to type your responses, you can just come off mute and share them very quickly. All right, okay. We have one in the chat. So Dave's team spent last Friday examining data to determine how students are doing this year. We then asked teachers to adjust the scope and sequence to finish strong, and finally teachers were able to visit in vertical groups. We found gaps and duplications in some area and found areas that need to be expanded. Okay, great. That sounds like a good thing. Having that opportunity to do that collaborative planning sounds like a great idea. All right, thank you for sharing that. Okay, and so our focus today is going to be planning and taking action specifically around small group and individualized intensive supports. The last time we were together, we looked at supports relating to whole group or small group acceleration support. So that was a different takeaway. And so we would like to look at those as like tier two interventions if you're thinking about like the RTI process. And so what we're going to talk about today is that small percentage of students who don't respond to the tier two support, and then we move them up to the tier three support, which is that intensive intervention, whether it be small group or whole group. And so we want to know that we think about our three key actions for acceleration: understanding, diagnosing, and then planning and taking action. We know that we've talked extensively about the first two steps in this process, about how we understand what the focus of the grade needs to be, and then how do we leverage how do we find quality diagnostics that are timely and are reasonable for teachers to unpack that data, and then to use that data and effectively to create plans for support for students based on where they fall in the spectrum. And so we are going to be revisiting these two key actions, but we're going to lean in on the third one, which is focusing in on that small percentage of students who need that intensive support, whether it be individualized or small group. So as we think about intensive interventions, I want to draw your attention to some research that's on the screen here. And so very quickly, the horizontal column or the horizontal table version, horizontal column or the horizontal row shows the grade levels from K to 12. And then the vertical column outlines the studies that have happened as it relates to these groups of students. The blue line shows, and you can see that most of the lines have like some type of length to them. It outlines the length of time that they've tracked the same group of students based on a very specific metric point. So I want to just lift up a few of these to you. So the one that's highlighted here, this research study identified a group of students in pre-K, and where those students scored at the pre-K level was almost spot on predicted where they would score in 10th grade in mathematics. Our other research did something similar where they analyzed scores from students in first grade, And those first grade scores were able to predict where students would land in 3rd, 5th, and 10th grade. And then in our final study that we want to highlight, it identified students in 8th grade and looked at those students once they were able to finish high school and go on to college. And their data point that they identified in 8th grade directly predicted their completion rate as it relates to completing a 4-year undergraduate degree. And so we share this information because what we know to be the case is a data point several years in advance, several years should not be able to predict future outcomes if we are actually intervening in a strategic and thoughtful way. And so if we looked at each one of these data points, if we are providing that just-in-time support that we've been spending a lot of our energy and time in these communities of practice discussing, then we should not be able to look at a single data point and therefore it predict how students are going to score. So we just want to lift this up to show how important it is to be very strategic and timely with our interventions. And today our focus is going to be how we are supporting our most vulnerable students with our intensive interventions. We also share that we know there are numerous research studies about how students score as it relates early grades, the success they have in future grades based on a number of varying factors, and how different students learn a certain way. Also, how the RTI process is in some situations are largely ineffective. And so what we know is if we are doing the interventions the right way, we will have a dramatic effect on the overall outcome of our students. Because as a lot of the research that we've looked at during our time together, we know that when students are given consistent access to grade level work, they will grow against those grade level standards. So we just want to keep those ideas in our head as we're thinking about intensive interventions for today. And so here's our agenda for today. We're going to jump into our next section, which is focusing in on the practice recommendations for mathematics interventions. And before we do that, just want to give you a quick 30 seconds to read our learning targets for today. All right. And so we're going to jump into the practice recommendations for math intervention. And we know that we've talked extensively about the different systems of support. So we know we have the core grade level instruction that we've talked a lot about. And then the last time we were together, we talked about the acceleration support. So that's like our tier 2 intervention. And then what we're going to lean in on today is that intensive intervention, which is that small group or individualized instruction that's targeted around specific skills using evidence-based high quality resources and strategies, including consistent assessments to monitor and measure student growth and progress. And this is just a quick visual. So we know that that core instruction happens at the tier 1 level. So that's when all students have access to that grade level classroom. And then based on the data that we're identifying, that we'll be able to pull from our students, we will recommend students for that tier 2 support. And then a small percentage of those students from that tier 2 bucket will need intensive interventions, which would be the small group or targeted individualized supports that we're focused on today. We also want to lift up this idea that there is no like magic bullet. There is not like one program that's going to directly solve all the challenges and all the issues that you see as it relates to the needs of our students. And so what we are lifting up is a strategic approach where you are blending in like an intervention curriculum, some type of computer-based program that's reasonable, and those resources are being vetted and aligned based on the needs of the students. So not just sitting students in a program and saying, oh, this program is going to solve all their needs, but there may be portions of that program that are beneficial to students. So you allow them to engage in the aspects that are actually going to serve them well and provide them that just-in-time support. And so as we think about where we start, so first and foremost, we want to assess where our students are. And so we've talked a lot about that, but in a couple of situations, we think about two ways where we're doing that. So, that first level is that universal screener. So what's that baseline assessment that you're giving to all students to get a general idea of where they are in their learning, what they're bringing to the table. And then from there, strategically, multiple times throughout the course of the year, you are identifying other data points that could give you information about where to best where students best need where students needs are and how to best serve them. So things like diagnostic screeners, interviews, having conversations with the student and the teachers, other people that work with that student, and also observing that student in the core classroom or in the acceleration support to then identify and drill down like specific things that will benefit that student or that small group of students. We also want to make sure we're identifying the right content. And so when we're thinking about middle school and high school, we've talked in our first session together about the focus area of each grade. And so the top rectangle has all the major work concepts that are aligned to 6th, 7th, and 8th grade. The one thing we know about grades 9 through 12 is that those grades do not have um, they have like major work to the grades, but they don't have like uh, clear delineations, because in high school, sometimes people provide courses, very traditional algebra 1, algebra 2, geometry, et cetera, or they do an integrated math series where there's an intermingling of multiple disciplines over the course of several years. So because of that, high school doesn't have like a specific delineation of skills. They have what was known as the widely applicable prerequisites. And these are the fundamental ideas that high school students should spend at least 50% of their mathematical instructional time engaged in these key activities, which are algebra, functions, geometry, numbers and quantity, statistics, and probability. So we always want to make sure we're clear about the right content as well when we're thinking about providing these intensive supports. The last thing we want to do is try to pinpoint when we're going to provide the support for students. And so we've talked at different times about having an additional intervention block that's outside of your core instructional time, but recognizing that schedules are set for this school year and you may not have the flexibility of identifying blocks of time outside of the core math block where you could provide this type of support. We're also lifting up this idea of how do you strategically structure the math block time where you could dedicate a segment of that block to regular intervention. And so that time could happen either at the beginning of class or at the end of class. And in my experience, I've seen it work well in both scenarios. And so what we're going to do today is we're going to look at some research that comes out of the Institute for Educational Sciences. This study was just released last month about assisting students who have academic struggles. And what we're going to do is we're going to focus in on a few of those items within the research. So we're going to lean into the first three as well as the last one. At sake of time, we're not going to be able to get to 4 and 5, but you will have a link to this research to allow you to do a little deeper dive into areas 4 and 5 at your own leisure. And so if we think about that first, and these are also on page 1 of your note catcher, the 6 recommendations for assisting students who struggle with mathematics. So as we look at this first key recommendation, it lists up this idea of providing systematic instruction during intervention to develop student understanding of mathematical ideas. And the reason mathematical ideas are bolded, because we're not thinking about mathematical skills. We're thinking about concepts and mathematical ideas that help develop students' overall understanding of mathematical concepts. And so to be clear about what systematic instruction is and what it isn't, I'll give us a moment or two to kind of read through some of those things before we move on. So on the left-hand side, you see some of the key ideas, what systematic instruction is. And on the on the right-hand side, you see some ideas of what systematic instruction is not. So I will give us a minute to read through those before we move on. All right. So now that you've had a chance to, read through what systematic instruction is, we want to just share some research around why this is so important. And so we all know that the NAEP assessment is like the report card of our nation. And so the NAEP assessment assesses students in grades 4, 8, and in grade 12. And what I want to do is just kind of draw your attention to a couple of pieces of data before we move on. And so looking at the two highlighted symbols in the key. So we're looking at students who scored in the 10th percentile and students who scored in the 25th percentile. And if we look at those specific data points from 2009 to 2019, which is a 10-year span, we've seen we see no positive movement, and we see a decrease in student growth over that 10-year period, which is very jarring considering the amount of energy and that's been put into teacher professional development, the use of college and career readiness standards, and this idea of giving students access to a high quality curriculum. So what this data tells me is that we often are saying that we believe in these resources, but we're not actually providing students these opportunities the way we see where we're getting the results that we want to see at the end. On the flip side, if we look at the students who scored in the 75th or 90th percentile from the same assessment, what we notice is these students who scored in the advanced category on the NAEP assessment, these students over the course of that same 10-year period have seen growth over time. So what it says to me is that we're doing a good job of supporting our students who are doing well. We're doing a great job of supporting them to grow, but we're not doing a great job of supporting our students who are starting the school year or starting their mathematical journeys behind their peers. And so part of the work of, or the idea of these intensive interventions is to directly support those students in the 10th and 25th percentile. And so as we look at what's actually going on, we know that we've seen a ton of studies that focus in on tier 2 mathematics instruction. And one of the things that's come out of that is that the majority of the work that happens in middle school is largely made up of worksheets, which means that we're not having teachers be critical consumers of high quality materials, and therefore designing lessons that are engaging and identifying tasks that give students multiple opportunities to deeply engage with the grade level content. This seems more like procedural skills and or busy work. And so one of the things we want to lift up, we know that there's some computer programs that do a great job of providing just-in-time supports, but we know that that shouldn't be the only thing that's happening in schools, because it's not by itself an effective approach to moving students who are already starting grade levels behind as it relates to students who are starting on grade level or above grade level. And one big takeaway we want to lift up is that worksheets plus a computer program does not equal understanding for students who struggle. And this comes directly from research that was done in the last few years. And so what I would like for us to do now is to look at a sample of systematic instruction in action. And so what you're going to do is you're going to turn to your note catcher and look at pages 2 through 6. And what we're going to do is we're going to have about 5 minutes to read the lesson excerpt vignette. And as you're reading, I want you to take note and be ready to discuss the following two questions. So what do you notice about the questions and tasks in the lesson? And then second, how does the sequence of the questions and tasks in the lesson support the student with making sense of multiplication of fractions? So just to give some framing, this lesson vignette that we're going to read is a teacher giving one-on-one support, individualized intensive support to a student. So we're going to see that work layout on pages 2 through 6. So I'll give us 5 minutes to read, and then we'll take 3 to 4 minutes after we finish reading to discuss what we notice, and then the impact of the sequence of questions and tasks that support the students' growth and development around making sense of multiplication of fractions. So I'll put 5 minutes on the clock, and then we'll come back together. Let's come back together in 30 seconds. All right, so now it's an opportunity for us to hear from some of our other colleagues in the space. And let's start with the first question. So what do you notice about the questions and tasks in this lesson? What are some of the things that you noticed? All right, Nick said in the chat, they started by accessing prior knowledge with the tell me what you know and then built on from there. Okay. Anyone else have something they want to add around the first question before we jump to the second? I also noticed that this was a real world scenario. It's actually something that could be something that's very reasonable for a student to understand. Um, Somebody's making some cookies and they're going to, share some of their cookies with and take cookies to school. It's a reasonable thing. Also, they started with very reasonable numbers, so that way the student had an opportunity to understand the content before they started progressively. The numbers started changing and getting more and more challenging, but the student was able to take the same knowledge from the original scenario and apply it to each subsequent scenario. So those are just some of the things that we noticed. And so does anybody want to lend their voice to the space around the second question? Have anything else they want to add before we move on about the sequence of questions and tasks and its impact on supporting the student with making sense of multiplication of fractions? You all are very talkative today.
I guess I come from an elementary background. So seeing this, like you said, is they're starting small, they're starting with numbers that are they can relate, they can actually see, they can visually, do stuff with. And then putting it, and then building from there is definitely going to help them understand that number sense part of it and getting really understanding that part before you can move on. And I think that is something that our kids really lack, is possibly that number sense. So the more I feel like they can touch it, they can see it, they can anything like that is going to help. So having a situation that, like you said, is an everyday thing, could be something that actually could happen, real life situations, is really important. So
Thank you, Katie, for lifting that up. And just want to put this out there. How would this lesson change if the first scenario was half of the cookie sheet and you had to cut it in half versus having multiple cookie sheets that you could easily visually see and break up into half of the value, or a third, and having to break that up into a half. So also being strategic about the access, although you ultimately wanted to get to the multiplication of a fraction by a fraction, you didn't have to start there to then get the student to that point. So basically building up to allow that student to have that access. All right. And so looking at ways on how we can carry out this recommendation, first and foremost, and Nick lifted this up, was that integrate previous content. So activating that prior knowledge is a key first step. We just spent a little time talking about using accessible numbers. So values that are simple for students to gain that first level understanding and then start to build in complexity so then they can apply that original scenario in a variety of situations, and also address misunderstandings and provide that strategic, immediate supportive feedback to help support and address students with their misconceptions. All right, and now if we look at our second recommendation, which is using clear and accurate language, the research says that we want to make sure teachers are teaching clear and concise mathematical language that supports student use of the language to help students effectively communicate their understanding of mathematical concepts. All right, and so very quickly, we have a short vignette, two math teachers talking about the same problem, and we're lifting up this question: why is this dialogue problematic? So I'll give you 30 seconds. I know you guys have been a little quiet today. So want to see if we can get at least one person to come off mute and respond to the question. What would make this dialogue problematic in a math classroom? So I'll give you 30 seconds to read and then looking for one person to share. All right. So what can you tell me that's problematic about this dialogue? We got two options. You can come off mute or you can drop it in the chat. What do we think is problematic about this dialogue?
The first issue that comes to Stevie, can you unmute? Can you mute yours? Yeah, but never mind.
All right. If whoever's in the space with you, they have to turn their volume off completely for you to be able to share. So we have a couple of responses in the chat. Stacy first lifted up, students do not know what a binomial is. Okay. The first dialogue is universal. The second dialogue is simply the answer for one exact problem. Okay. So I'm gonna start with Stacy's. The first issue is that this will only engage one or a few students. Okay. I agree with all of those statements. I think one key thing is that in both statements, we see the use of academic language, but there's no explanation about what the academic language actually entails. So there's definitely an assumption that students already know what these terms mean. The other thing is there is an opportunity. This looks like only one method for solving this problem. As we know, there are multiple ways that you could go about finding the product of two binomials. And the only way is not we always multiply the first term of the binomial, the first term in the binomial by the entire second binomial. That's not always that's not the only approach that we could take. It is a approach, but it's not the only approach. So maybe a better question could be, how many ways can we solve this binomial? Or how many ways can we simplify this expression? something that's open-ended that allows for multiple representations, that allows students to share their knowledge and what they've already learned and different ways to go about answering this question. Because someone may lift up, oh, we can draw an array or use the area model in order to simplify this expression. So just a couple thoughts around that. So what we're going to do right now is we're going to read a quick vignette. And this vignette lifts up a conversation between a teacher and a student around subtracting with regrouping. And so we lift this up because it has very strategic use of mathematical language in action. And so I just want to give you a moment to read through this very quickly, and then want to think through and respond to just the first question. So how does the teacher prompt the student to use mathematical terminology in her explanation? So let's take 2 minutes to read this vignette, and then we can share very quickly around the first question. We'll come back together in about 30 seconds and be looking for someone to come off mute and share their response to the first question. All right, so as we come back together, we're looking for one brave soul to come off mute and then share their response to the first question. All right, so Nick is making sure we don't have an awkward silence. I appreciated Nick by dropping that in the chat. So the teacher starts by reminding her of the mathematical language that should be used and then modeled using it to reinforce the language. And you can see a gradual change in Carrie's language throughout. Well said. So making sure we are constantly providing that feedback and reinforcing it, and then making sure we are also modeling the appropriate way to use it. And as a transition, we start seeing the student make the connection between the words they use and that mathematical language, and then apply the use of the mathematical language as part of their own explanation. So very well said. All right, and so just very quickly, the ways we want to carry out this second recommendation, we want to focus in on building that mathematical vocabulary. We want to use clear and concise mathematical language and support students reinforcing the use of it. And last but not least, we want to support students in using mathematical language precisely, and then having that show up as within their explanations of answering a problem or completing a task. All right. So as we jump into our third recommendation, which is multiple representations, we want to look at and think about a well-chosen set of concrete, semi-concrete representations to support students' learning of mathematical concepts and procedures. And once we provide students with a concrete and semi-concrete example, then we can go ahead and move on to the abstract. And the students can see the connection between those first two examples and that abstract example. So one quick explanation of this is if we're thinking about function notation or a linear equation, we can start by modeling the difference from one figure to the next. So in the first visual that you see, we see that this figure is growing from figure 1 all the way to figure 4. We could then talk students through an input-output table or an input-output machine where they're putting in a value and it's spitting out a number. We could also then transition that to a formalized input-output table. And then we could help students see, once we've been able to show them that input-output table, that those values represent an ordered pair. Those ordered pairs can be points that are plotted on the coordinate plane, and they follow a specific pattern, so they can represent a linear equation, either written in slope-intercept form or function notation, which would be that abstract example. Another way to think about representations is think about how we give students another way to communicate some very simple ideas or simple concepts that allow for deeper understanding and exploration. One quick example that I like to use is the idea of square numbers. So we know all the square numbers, like 1 squared, well, the outcome is, so 1 squared is 1, 2 squared is 4, so forth and so on. But what if we also gave students another representation where we showed them an array or an area model that represented that same thing? We could then take this same example and think about the volume of a three-dimensional figure, and then see that they could actually count the actual cubes, for example, and then see that that represents the volume of an actual figure. So just thinking about multiple representations and using like visuals as a way to support students with deepening their understanding. All right, and so for sake of time, we're not going to be able to watch a video, but we will have an opportunity to watch a video a little bit later when we talk about fluency. And so when we talk about multiple representations, we have these recommendations. We have these ideas to carry out the recommendations. So first, choice. So you want to provide students with concrete and semi-concrete representations that effectively represent the content, the concept or procedure that's being covered. We then want to see those concrete and semi-concrete representations connect to a larger idea, which will allow them to see the connection between those two pieces and the abstract representation. And finally, we want multiple opportunities for students to revisit these examples or these representations periodically to reinforce and deepen their overall understanding of the mathematical concept or idea. All right, and quickly to summarize, thinking about what's effective for small group and individual intervention practices, we want to make sure we build a strong mathematical understanding in and across lessons through systematic instruction. That was our first recommendation. Our second recommendation was to use clear and concise language that is consistent with future mathematics learning. Third, we want to have explicitly connect concepts and procedures by having well-chosen concrete, semi-concrete, and abstract representations. And we want to move away from doing things like just isolated drills of procedures and skills. All right, now we're going to jump into our second section, which is focusing in on building fluency. And so when we talk about fluency, we first must also talk about the different types of unfinished learning. So there are two types of unfinished learning. Unfinished learning can be conceptual in nature, or it can be procedural in nature. And the quickest way I can describe the two is that conceptual unfinished learning, there is something that teachers must directly do prior to giving students access to grade level learning. So what do I mean by that? If a student's unfinished learning is conceptual, that means they're lacking some critical foundational prerequisite knowledge that is going to be essential for giving them access to grade level learning. So just like what we've talked about, that just-in-time support, if you identify that grade level learning and you know a student doesn't have that prerequisite skill, then you provide them access to the prerequisite skill prior to giving them access to the grade level learning. So in this case, conceptual unfinished learning has to be addressed prior to giving students access to grade level learning. Procedural unfinished learning, on the other hand, just talks about students may have a basic understanding of the mathematics behind the concept, but they're not fluent in the skill of answering the question or applying the procedure for the skills. And so we'll look at two quick examples of both conceptual unfinished learning and procedural unfinished learning. So our quick example of conceptual unfinished learning is that a 7th grade student must have understand the concept of a ratio, which is part of the major work of 6th grade, in order to analyze proportional relationships and use them to solve real world mathematical problems, which is the major work in 7th grade. So we would provide that on-ramping, leveraging that 6th grade standard, then give students access to that 7th grade standard. In our procedural unfinished learning example, we have a 4th grader who's not yet fluent with their basic multiplication facts, but that doesn't stop them from being able to engage in the grade level learning of dividing multi-digit numbers. That grade level standard of dividing multi-digit numbers, we recognize that students aren't fluent in it, and we want to provide them with multiple opportunities to grow around that basic area of multiplication facts while engaging in the grade level learning. So that student in this case, that not being fluent is not going to stop them from dividing multi-digit numbers. It might make it a little bit more challenging, but as part of that work, they are going to be practicing the basic multiplication facts. So by giving them access to the grade level work, you can reinforce and support that procedural unfinished learning. Okay, and so I want to take a minute or two to give everybody an opportunity to just share out in the chat how they would describe the word fluency. So let's take about 2 minutes looking for everyone to share their responses or their thoughts in the chat about how they would describe the word fluency. And then we'll come back together in about 2 minutes. All right, so we definitely have some great responses that are coming in the chat. So uh, Sandy got us started with saying fluency is so students can complete math problems quickly and more easily. Then we have fluency is being able to conduct mathematical processes with little to no errors. It's doing mathematics quickly. We have another follow-up, efficient and accurate methods for solving math, the ability to construct or complete a task given a basic working knowledge of from prior examples. Fluency is being able to say facts quickly so they don't need to spend time to figure out the facts. And so these are just, thank you for sharing your thoughts. This next slide that I'm going to share with you just shows some things that fluency is and some things that fluency is not. And so I'll just give you a moment to read through these as I am popping them up on the screen. So if we notice this list, just kind of lifts up a lot of things that you all were sharing in the chat. So I think we're on the right track. But we also noticed there are a few things that this list lifts up that fluency is not. So just want you to take note of that as well. And so one myth about fluency is that some students are better off knowing just one way. And we know that's definitely not true. There's a lot of research that says that students are better off knowing a set of useful strategies and knowing how each is useful and when they are not. So we know that if we have the opportunity, we want to show students multiple ways to attack a problem as opposed to showing them one way, because that's going to give them that connection to those different representations, which definitely connects to deeper understanding of mathematical concepts. All right. And I want to share with you a quick example about fluency. And I'm gonna give you, there are two students. And the problem is students have to multiply 15 times negative 19. So student A is going to pop up on your left. Student B is going to pop up on your right. My question is, which student is showing you evidence of procedural fluency? I'll give you a moment to read both of these. And when you're done, go ahead and drop the letter in the chat that you believe represents the student who is showing you evidence of procedural fluency. Take about 20 more seconds. Go ahead and drop the letter that you think represents the student that's actually showing you clear evidence of procedural fluency. So Nick said that he believes A, and that's how he would arrive at the answer. And so B is also, Sandy just put B as more formal, but A is more common sense. And so sorry about that, Nick. But I think the fact that you said that you would answer the question that way is that you're thinking like a mathematician. What's the most efficient way to answer the question? Student B, both students got the same answer. Student B is following the standard algorithm for multiplication. Student A is understanding what multiplication truly is, and is leveraging what they know about multiplication to simplify the process for arriving at the solution. So the answer to student A is looking at a strategic process to thinking through mathematically what's the most efficient way to find the answer. B is the standard algorithm. B is not wrong, right? B is definitely more traditional. But if we had to say which one would show us clear evidence, what B did was that would be paper and pencil. What A did, that would be something that somebody could think through very quickly in their head without the use of paper and pencils. That's more mental math than it is like actually writing it through, because you would have to take a lot more steps to keep all the information in part B together versus how student A went about answering that question. All right. There's another myth that says students first learn the concepts, then learn the procedures. And what the research says is that students should develop conceptual understanding of the procedures, and they should proceed and coincide with the instruction at the same time, because having students see the connection between the concepts and the procedures is a critical piece as part of the puzzle. Just like we talked about students seeing the connection between multiple representations was also very important. All right. And then this is just another research data point that's telling us that when students were given multiple strategies, so the strategy group was given multiple ways to attack a problem, and the non-strategy group was given one way to attack a problem. Over time, the strategy groups always outperform the non-strategy groups, because that just makes perfect sense. Students have multiple ways to attack a problem. So when they see problems, they have better attacking and coping skills of how to manage and think through the best ways of solving that problem. In the same scenario, strategy groups did a better job of retaining facts than the non-strategy group. And we know that another key point is that the use of strategy definitely predicts success in math when we think about it in a general sense, because if you're given a problem, if you have multiple strategies, you can attack that problem from a lot of different areas. And one strategy will start to give you an idea of how to answer that question, even if you don't truly know like the algorithm or the process to answering that question. All right. So what we're going to do now is we're going to look at a very short video of a number talk. And we're looking at an 8th grade classroom. And in this 8th grade classroom, the teacher is having students engage in a number talk around subtraction. So if you bear with me for one moment, I'm going to stop sharing my screen, and then I'm going to share the video.
So remember, our procedures are up top. We have, especially then it needs to be quiet while people are explaining and while you are thinking for your mental math. That's the most important. On Monday, remember we started with subtraction. So we're subtracting from our same difference. We took our minuend minus our subtrahend. And we talked about the number line. To get to our closest 10, we add 2 to both our minuend and our subtrahend. This means they move up the number line the same amount, so there's still the same amount of numbers in between 2. So on Monday, we used that skill and you guys came up with more, okay? So we're gonna start off with a review from Monday with easier numbers, and then we're gonna keep getting harder and harder as we go along with our 3 examples, okay? So first one, we have 52 minus 16. I wanna see at least 2 strategies. fill in what's one strategy.
I subtracted 52 minus 6,
Okay.
which is 46. And then I subtracted the 10, which is 13.
What was your answer? Okay. 36 yes, 36 no. Got it right. Yes, very good. Okay, another one. 52 minus 36. I saw a lot of you with 4 strategies on your hand. Gianna.
So I started with 2 from the 52, and I subtracted the 6 from the 16, which left me with -4. Then I did 50 minus 10, which was 40. And then I added 40 plus -4, which is 36.
So you took -4,
And
added 40, and got 36. Perfect. Using our negative numbers. Nice. Amun.
What I did was I added 4 to 16, and then I added 4 to 52. And that was 56 and 20, and then you subtract that and get 36.
Nice job using the skill of same difference. Kayla.
I subtracted 4 from 16.
You subtracted 4 from 16, and you got 12.
Subtract 12 from 52.
Okay.
40.
This one down here. Subtracted 4. 40 minus 4 is 36. So we don't want that arrow because he just moves the 4 over to the other side. Perfect. Good. So those are our 4 that we came up with. So that's lots of different ones that we already have. Are you ready for harder?
So we saw a few different ways the students were able to find the solution to 52 minus 16 in the video. And so here's the question that I'm posing to everyone, and I'm going to put us into breakout rooms where we can discuss the following questions. So how did this practice encourage the use of strategy? And then how does this fluency practice compare to your school's approach to fluency practice? So those are our 2 questions. I just dropped those same 2 questions in the chat. So while you're in your breakout groups, you can refer to them. We'll be in breakout groups for about 4 minutes. Our breakout groups are pretty small. It's about 3 people in every group to give everybody a chance to talk. And then we will come back together. All right, I'm sending us all to breakout rooms now. All right, sending everybody to breakout rooms now. All right, so welcome back from the breakout rooms. We had a little conversation that was going on about how the importance of having multiple approaches will give students more opportunity to unpack and solve problems. I didn't hear all the conversation, but I liked the part that I heard about having, I think it was Nick that said, the more tools in your toolbox that you have, the better you are with solving problems. So I definitely appreciate you all lifting that up. The key points about this section is that, fluency is more than just the basic facts. I think it's important that students have those facts. I definitely heard someone lifting up the idea that the more facts that you know, the better you could be long-term for advanced mathematics. But in the moment, if a sixth grade student doesn't know their multiplication facts, like memorize, it doesn't mean they don't have the ability to access sixth grade content. And I think that's the more important piece. And so if we know a student isn't fluent yet, what can we embed in our instructional program to give them the ability to grow that fluency? Because one thing that's very important about fluency is when you look at grade by grade fluency, it doesn't mean in the moment fluency, it means end of grade fluency. So a lot of the work that's done within the major work of the grade is to support the fluency expectations that students need to have by the end of the grade. So like in 8th grade, students should be able to solve one-step equations fluently. That doesn't mean in October in 8th grade, they don't know how to solve it fluently, all hope is lost. They will have multiple opportunities over the course of the year to improve in that skill. That's why, as we think about the 3 aspects of rigor, there's a balance between conceptual understanding, procedural skill and fluency, and application to ensure that students have that opportunity to grow over time. As we wrap up, because we're coming up on the end of our time together, on page 12, I just want to draw your attention to a call to action. So part of the reason why we spent time over the last few months doing this learning was to identify what our next steps would be. So you have a list on page 12 of 5 call to action examples. As we close out today, I just want to draw your attention to identify one of those 5 for yourself, and identify something that you're willing to commit to over the next 2 weeks to move the needle forward as it relates to supporting students who have unfinished learning. We've all gone through these trainings since January. And so what are we going to do now in the next 2 weeks that's going to have a positive impact on our students? Or what are we going to do over the next 2 weeks that's going to provide that leverage of support to grow that teacher's practice so they can be better at providing supports for our students, whether it be whole group, small group, or even intensive interventions. And with that, I just want to say thank you for your time. I know that, sacrificing any time throughout the course of a school day is difficult and challenging. So I want to say thank you for sticking with the communities of practice. I just dropped the link into the chat. We definitely take a moment or two to complete the survey. We definitely want to hear from you as it relates to the feedback from this session. What worked well, what didn't work well. And with that, I just want to say thank you for your engagement over the sequence of the last 3 months. Good luck with the rest of the school year, and good luck with your work in the summer and next year as well. I'll stick around